Hello everyone. Till the last video we talked about noise, we talked about crosstalk, we talked about the impact of crosstalk, delta, delay on timing. We saw all those things, and we also concluded that the protection, the noise protection should be done well in advance or should be planned well in advance. But what if it is not planned, and there are some noise which are present towards the later stages of the chip tape out. So in that case, you need some quick noise protection techniques, though these are not so quick noise protection techniques, but there are some ways to avoid it. There are some techniques that you can avoid the noise. So in this videos and some videos from now, we'll be learning about how to protect the noise in the later phases of tape out. So for example, we'll take our same classic circuit that we have the aggressor over here, we have the victim over here. Okay, and this let's give the nomenclature. So the aggressor net, this is the victim net, and the technique that we are going to learn over here is the shielding. So before entering into shielding, the noise was happening because of this aggressor is placed very close to this victim. So basically this aggressor was very easily able to attack this particular victim. So the best way to protect this victim is to shield it with some walls, with some nets. So the shielding can be thought of something like walls. So for example, you have a classroom over here, this one of the classroom, this another classroom. When the professor teaching in this particular classroom with a loud voice, that voice might enter this that voice might enter this particular classroom, and this professor might get disturbed. So what is the best way to avoid these two classes to interact with each other? It's that you put a wall in between the classes. As a result of that, what will happen, the voice of this particular professor will be contained in this area itself, and the voice of this professor will be contained in this area itself. So as a result of that, we are protecting this particular victim from any outside disturbances that is happening. So this is nothing but a shield. So it's very similar to a raincoat. For example, a person uses a raincoat to save himself from rain. In the similar way, this particular victim is being protected, is being shielded by this particular shields. And when we talk about shields, shields are nothing but they are wires. They are thick wires which are present across this particular victim kinds of net. They are not present on all the nets, but they are present only across selected nets. For example, this particular victim net. So towards the end phases of the tape out, we select some handful of nets. We select some handful of victim nets which are very deeply impacted by the aggressor, and we shield them. We do some techniques of shielding them. Either we do manually or we do some automated techniques, but the concept is to shield, to protect this particular victims. Okay, in this case, now any switching activity that will happen on the aggressor will not directly impact the victim, but it has to go through the shield, and the shields are so tough that it's very difficult to cross this particular shield. Basically, any activity that is being happening on the aggressor, it's very difficult for that activity to be seen by the victim because of this huge walls which is present over here. Now the shields which are present over here, it's like wires. They're just wires. So the shields can't be kept as floating, because if they are kept as floating, the impact of the aggressor switching will be present on the shield itself. So as a result of that, what we do, we connect this particular shields to some logic level. For example, there are different school of thoughts of doing this. One school of thought is you connect the shields to the VDD. Okay, both the shields to VDD, or you connect the shields to ground, to the VSS, or you take one of the shields and connect it to VDD and the other one to ground. But in all the three techniques, the common thing was the shield has to be connected to some strong logic voltage, to some strong constant voltage. It should be a constant net, and the logic voltage or the point at which it is connected to, that should be strong enough to supply the required amount of static voltage or the required amount of constant voltage. In this case it's VDD. So if it is directly connected to the supply is the most powerful source of your your constant logic 1 or your constant logic 0. So once anything connected directly through this to the VDD, the VDD will make sure that this net will be constant at VDD. The VSS will make sure that this particular net is constant at ground. So this particular supply sources in the cases which was present over here or which was present over here, the nets were connected to the supply through some MOSFETs. In this case there are no MOSFETs in between. The shields are directly taken out and connected to supply voltages. Okay, this makes it very sure that the shields will be constant, held at constant logic 1 or will be held at constant logic 0. So now the advantage, if you see over here, now the first question that we have to ask is how come shields when it is tied to logic 1 or logic 0 protects the victims? Okay, how does shielding basically solve the problem? So it's basically the truth lies behind the concept that the shields are connected across the VDDs and ground. Basically they're connected to constant supply voltages, which is VDD or ground, and the VDD and ground don't switch. And since the VDD and ground don't switch, they make sure their victim don't switch. So as a result of that, if nothing is switching, if there are wires across the victim which don't switch, the victim is safe, the victim is protected. But yes, if there are some jitters which is present on the VDD itself, that will affect the victim, but that's a different story, because we have some way to protect the shield itself. There are techniques where we usually go for a mesh kind of power routing. So those are like power related stuffs where there are separate set of videos where we'll be talking how the power grids are made. But the power grids does make sure that this particular shields are constant at logic 1. There are no disturbances in the power supply, and as a result of that there won't be any disturbances in the logic level of the shield. And since the shields don't switch, they are very good sources to protect this particular victim from any nearby aggressors. But there is one disadvantage that we see with the shields, and the disadvantage is that we have huge number of routing resources if we have to do this for each and every net. For example, if there are 1000 nets, each net will need across 2 shields, so it's 1000 into 2, like 2000 shields. So the routing resources increases from 1000 to 3000, and as a result of that, what we do is we don't shield each and every net over here, but we start from the clock nets, because clocks are the one. Basically we start from the critical nets. We start shielding from the critical nets. So for example, clock is a very critical net that is switching across over the time, and it needs to be protected. And the reason the clock needs to be protected is we don't want the clock frequency to change. And as a result of that, what we do is the initial level of shielding is done only for the clock sources, only for the clock routes. For example, if this was present in the clock network and there was a flip-flop present over here, this net would have been by default shielded. So the clock nets, critical nets like clock, are by default shielded. And for the other nets which we see getting impacted, for example, if this was a part of a data path, okay, in that case we select some handful of victim nets and shield them in order to protect it from the aggressors. And these nets are identified only at the later stages of the tape out phase, where there are no ways to do. So there are some this is one of the techniques to protect the there are other ways also. This is one of the techniques to protect the victim, the handful of victim nets with shield, which we know they are deeply impacted by the crosstalk. So this is the way we pick up a handful of nets and shield them. This is one of the techniques. There are other techniques as well which we'll be talking in some time from now, but this is one of the solid way of fixing crosstalk or protecting the victims against the crosstalk nets. So what we'll do is, since I'm running out of time, shielding is one of the technique. We'll be looking into two more techniques in the upcoming videos. So there is one more technique where we space the nets, where we space this net and this net a bit apart, and then there is one more technique where we upsize or downsize this cell. So let's try to look into all those techniques in the next video. Thank you.